All right, for the next shape we'll be doing in surface area is the triangular prism. So triangular prism is basically very similar to a rectangular prism, except that instead of rectangles or squares on the side, we have triangles on the side. And they're all just connected together, which leaves kind of this tent-like shape behind. So the surface area of a triangular prism is just like a rectangular prism in that it's the sum of the surface area of the different faces of this triangular prism. But you'll notice right away that there are many different types of faces instead of just the common rectangle like we did in the rectangular prism. So let's analyze these faces one by one. What kind of faces are there? First, there's a very basic one, the rectangular face on the bottom right here. Let's label that right here. We have one rectangular face on the bottom that makes the base, and this has dimensions W and L. Just very simply right there. Next, we have the surface area of the triangles on the sides. Let's draw them right here. Since there are two, we're going to do 2 times this triangle area right here. And we said that this triangle has height H and a base of length W. The formulas for these areas should be pretty simple, but just to go over it, the formula for a rectangle is just width times length, which in this case very conveniently simplifies to WL. The surface area of triangles are 1/2 height times base, which in this case would be width, or W, and we'll talk about that later. And finally, in this triangular prism, we have these sides right here. These are also rectangles, except they're very different from what you would think. So to calculate for these rectangles right here, you have to first look at this triangle on the side and determine what kind of triangle is it. Is it a right triangle, where it's just 90 degrees and it's just pushed over like that? Is it a triangular prism like this? Is it a triangular prism like this, where the sides of the triangle are isosceles or equal? Or is it a triangular prism with scalar triangles on the ends? So that means none of the side lengths are the same, and that is just a random triangle lying out in everywhere. So nonetheless the case, let's analyze these two faces separately. So looking at this face right here, you'll notice that right away you could say that the surface area of this face right here is length times this slant right here. Let's label it slant I. This is slant 2. We're calling it slant because with a triangle, of course, it's slanted. So let's analyze slant 1 first. With slant 1, you'll notice that since by the definition of a height, this angle right here would be 90 degrees. And since it's 90 degrees, you could look at it and realize right quickly that this shape right here is a right triangle. Once we see a right triangle and we want to refine the sides of this right triangle, we could think right away to one of the most popular theorems in mathematics, the Pythagorean Theorem. So the Pythagorean Theorem just relates the magnitudes of the sides of a triangle, and it does so by determining first the sides of determining the magnitudes of 2 sides of the triangle and using that information to deduce the last one. So let's say that right now, this W length right here, I'm going to erase the different kinds of triangular prisms. Let's say that with this width W, the width W is split into 2 lengths of length A and length B. And these lengths are defined by are added together to form the width. So what I'm saying is that A plus B is equal to width equal to W in magnitude. A and B can be defined by the different sides on the point that H drops down to the W length. So now let's analyze S1. If we look at the triangle for S1, you'll notice that right here is B, right here is H, right here is S1. And since this is 90 degrees, we know that HB squared plus B squared is equal to S1 squared. That means S1 is equal to square root of H squared plus B squared. Pretty simple. We can do the same thing to S2 and just duplicate it, but in this case, S2 would equal to square root H squared plus A squared. All right, so don't worry about all these different variables, because usually when in a problem, they'll tell you a certain number of dimensions and enough dimensions so that you could deduce any other lengths that you may not know about this thing. But just remember that A plus B will always equal W, since that's the definition of how we laid out A and B. And that the sides A and B and H and all the different slants of this triangle are related by the Pythagorean theorem, and you could use this Pythagorean theorem to deduce anything you might not know. So with all this, we can now determine the surface area of this triangle. So we went back over here, surface area plus these two different shapes, and now we're going to talk about the slanted rectangles we just talked about. So this has to equal another rectangle. Let's talk about slant 1 for now. And this rectangle right here, I did not do a good job drawing that rectangle. This rectangle right here has side of slant 1 and has the bottom of length L. The final shape we have to add on is the other rectangular area right here that has side S2 and still a bottom of L. So we're going to summarize the SA area right here. The surface area of this triangular prism is equal to WL for the bottom rectangular area of this triangular prism, plus 2 times 1/2 of HW, which is the areas of the triangles. But since it's 2 times 1/2, we can cancel that out, but I'll write it anyways. We can cancel this out to just be plus HW, plus these two areas, so slant 1, L, plus slant 2, L. And we could simplify this slant even further to its components, which is equal to, let's write all this out, plus L So that's the final surface area of this thing, of the triangular prism. And I should probably write it somewhere more clear. Write it one more time. So finally, with, oh, I should not have erased that. Oh well. With that area, triangular prism. The surface area of this is equal to WL plus HW plus length times square root. This is B, this is A. B squared plus H squared plus length times square root of A squared plus H squared. All right.